Our company, known as Robot, also known as F62, consists of me, AJ, Caleb, Yash, and Milo. And we have solved how to do labor in harsh conditions and environments with heavy equipment vehicles. And that's to just take the operator out of the seat. And to do that, we use a cobot as a receiver and the controller, which would be right here, our robot, which would be there. And the harsh conditions that we would be talking about would be things like oil spills and toxins in the air. And so essentially, if we just take the driver out of the driver's seat, he can have control with the controller, and that would eliminate the safety issues with having a live human being inside of these vehicles to put them safely away at a safe distance.
Here's our design matrix. Design 5, or option 5, is the best one. It's 2 joysticks and 2 buttons. The joysticks are actually in the button. It's based off ergonomics, Z-axis, grip, tank drive, stall protection, how hard it was to code, and how hard it is to drive. And then we attempted to do design option 4 with 2 joysticks and 1 button, where each button, every single time you press it, it would do an automated sequence essentially, where 1 button would open the claw and lower it, the second button press would close the claw and raise it, the final button press would open the claw. However, it was kind of really hard to code, and it didn't really function with the robot, so we just switched to a toggle, which was option 5, where it would lower and raise the arm with the left button press and then open and close the claw with the right button press. Here, we can actually show our control design where it's open, where we have our 2 joysticks, and then our Arduino Uno. We go up here, we can lower and raise the arm on the left joystick, and we can open and close the claw on the right joystick. Left joystick moves left motor, right joystick moves right motor. It can move forward and backwards. And we got a little dance as well. That's it.
Transmitter pin layout showing how it's connected to the R4 Arduino. So our left and right joystick get 5 volts, and the right joystick and the left joystick both get ground. The right joystick X and Y go to A0 and A1. Left joystick X and Y go to A3 and A4. And the digital pin 3 and 2 are for the left and right joystick click buttons. This is our receiver pin layout, which shows that we have 5 volt and ground going to our H bridge and our servos. We have the up and down servo position as A0, our gripper servo position as A1, left and right motor direction 1 goes to A2 and A3, which we're using as digital pins. And pin 8 is up and down servo PWM. The pin 7 is the right motor direction 2, and pin 4 is the left motor direction 2. And the right motor speed is 6, and the left motor speed is 5. And those are both PWM signals. And our last is the gripper PWM, which is number 2.
So this is the transfer code. So we have our day structure here, and then we have our password, which is penguin1, and then your pin assignments, which controls everything for our transmitter. We have our setup here, and then we have our main loop here, which is basically the left pin, left joystick and right joystick. And then we have our reading the analog of the joystick, which is L, L, R, R for each one. And then once we have all those inputs, we then send it in a packet, which is in the Wi-Fi serial.send data, and we send it over to the receiver end, and yeah. This is the receiver code, so this is the day structure, Wi-Fi setup, pin assignments, objects and variables, server position limits, function declarations, this is the setup, and then this is the main loop here, where basically we get the code from the transmitter, and it goes through, and then it does everything else. This is more control here. And then we have our server right, and then server control, where if it's more than 3 seconds, it'll do it. If not, then it doesn't. And then basically it does all that. And then there's a victory dance. If it's more than 3 seconds, it does this whole code here. And then it'll reset the servo for it'll do the whole operation.